Hey guys, I just picked up the Ariel Rider D, the dual model, and this thing doesn't work. There's a couple things broken with it. I got it for about 200 bucks. Comes with a dual motor configuration, and the guy was just getting rid of it. And it had some dings, some scrapes. He wanted 600 bucks for it. He dropped it to 300, then I was able to talk him down a little bit more. The throttle doesn't work. This is the throttle cable. I think that's probably the issue with the throttle. The 3-speed switch doesn't work, so this front motor isn't working. Hopefully the 3-speed switch is the thing that's making that break. I don't know if I can get that front one to work, but we're gonna try. And then the battery is completely dead, like completely. And we're gonna try and actually get that running as well. So that's the first thing we're gonna do, is see if we can actually get this battery to run. We're probably gonna have to rebuild the battery, but I do wanna see if I can actually make it work. So I've got my cycle satiator. I'm at 48 volts, and let's just see if we can bump start this sucker. Go ahead and plug it in. It's not gonna notice. I'm gonna try and hold to start it. It's gonna say connect battery. We're gonna try and force start. 8.6 volts. That did not work. It's gonna drop down to about 8.6 volts. And I imagine there are just a couple of strings on this battery that are just completely dead. So we're going to go ahead and take it apart. We're going to take it off the cycle satiator. This battery is not coming back to life. Let's go fix it. So the first thing I want to do here is take apart the cover and figure that out. There were 4 screws here, fairly easy to take apart. And then there were some clips that gave me some trouble. So I'm going to skip ahead here just a little bit. Once I got the 4 screws out, it looked like it wanted to come apart, but there were some clips or something in the middle holding it together. It was really hard to take apart, so I was trying to get into it for a while. So I'm just trying to pry it apart here. I could only see the 4 screws that we saw on top. However, it looked like there were some plastic clips on the inside, or at least that's what it felt like. So I'm just going to kind of try and take it apart and slide my screwdriver through here and see if I can pop any of those plastic clips. And looks like we got it. There was a plastic clip, as you can see right there. So plastic clip on the top and bottom, and now we have the actual battery case and the exposed wiring. So now there's 2 more screws here just holding that connector in, which has the light on it and everything else. There's a switch that appears to do absolutely nothing with the battery, so I'm going to have to cut that eventually. There are 4 more screws here. We're going to take off the screws on this case, 2 on each side, just like before, and then we're going to pop the cover off. Screws are out. Now we can go ahead and pry it apart. This was the exact same thing as before. There were some clips. Actually, the clips were slightly different here. There were 2 clips. One on one side, one on the other. It took a little bit to get them off. Again, those were kind of difficult. I had to rip apart the case just a little bit, made a kind of a mess, and then this was glued inside of this particular case. Looks like it's a fairly compact 18650 battery, but we should be able to get it apart. I do want to stress that you really do need to be careful when you're taking apart any type of 18650 battery. These are live cells. There's no way you can turn them off. All there is a BMS for protection, and we're bypassing the BMS when we do something like this and take them off. So definitely be careful when you're doing this. I did a one last ditch effort to connect my balance charger to it to see if I could bump start it with like an MH charge, and that did not work. Some of the cells are entirely dead, because they're all in series. Some of them are just completely dead. Going across 4 cells, I think I got 1.1 volts. So it's a very, very dead battery. So we're going to set this aside, and we're going to take apart some of this hard housing that's around it, and we're going to use it on the new battery. But we're essentially going to rebuild this exact same type of battery because I want to fit it inside the same form factor that they had it before, and it was very, very compact. So here I'm just desoldering the BMS. I think the BMS is still good, so we're going to try and reuse the same BMS on the new system. That way we'll just have brand new cells that can manage it, and it should be just fine. So I think the biggest issue here is that there's 5-year-old cells, and the guy killed it by leaving it out in his garage for way too long, and the cells just got below their threshold, and there's really no coming back once you get under, zero point 0.5 volts. You have serious degradation that happens, and it's just, everything's not good. So that's fine. We'll take these off. You can see they're already cut to size, and it's a super basic battery build. There's nothing fancy going on here. It's just using just standard cells with a generic BMS. So this battery is headed to the recycler, just putting some tape on it. I did want to see how they configured the battery, again, just for reference, just so I can build mine to hopefully the identical specification. And I don't really have any batteries that I can use specifically for this that are new. However, I do have a used battery that I built a while ago. It was for my Razor e-bike. And this giant massive battery you see on the right, this was my Razor e-bike build. It was a 26 amp hour, 48 volt battery. Really, really massive battery. However, it had issues. So it worked fine for me, but then I sold my e-bike to like a local kid who liked to take it off jumps, and his battery was not meant for hard enduro. It eventually cracked and it destroyed the battery. I ended up fixing it about 3 times before it gave up the ghost. But I mean, the cells are still good, but the actual battery itself, like the construction, was not meant for high impact anything. So I'm just going to take this battery apart. There are 10 cells in each one of these packs right here that I'm going to take apart. So each one of these has 10 cells. I did a heavy amount of soldering on it. I think I'm going to take 9 of these cells. There's one of these cells that's pretty heavily soldered. I'm not going to desolder it and add a bunch of heat to it. I'm just going to put that aside and just assume that battery's dead. But I can harvest 9 of these other cells, and I should have plenty of cells. All I need is 78 cells to rebuild this battery pack. So I've already got the cells ready to go. They're 2600 milliamp hour cells at about 98% capacity. So that's going to give me a 15 amp hour pack once I get this configured. The other pack was an 18 amp hour pack, but of course it's dead. So 15 amp hours is going to be good enough for me for this dual motor configuration for now. So here's a time lapse of me just ripping all these apart, and it is fairly time consuming, but here you go. So here we're actually building out the 15 amp hour rebuild of the entire battery. We're putting 13 series cells together. We're separating them with fish tape, and then we are going to use the SEE SII CSI 801D spot welder. So this is new that I purchased off of Amazon. I'll link that. It's actually really cool. So I was using a battery style welder before. That one was really nice, but I had to charge the battery, and they said to not charge the battery while you were welding, so that was a little frustrating. This is pretty cool because it's slightly more industrial. It does take 20 minutes to charge, but you can weld as much as you want. They weren't even getting warm, these terminals, so I was just able to weld the cells as quickly as I wanted to, and it worked out pretty well. So I'll just be finishing up this battery, and I went through the entire section here. I just completely went over one side, flipped it over, and then I did the entirety of the other side. So I believe that's the positive side right there, or that may be the negative side that I'm working on. I can't really tell from here. But we're just putting 2 strips down, and then we're putting 1 strip across. When it comes to the amount of current that's coming through this, we have a 30 amp BMS, and we have 6 cells, and with the 0.12 spot weld, the thickness of the material I'm using, I really only want to put 7 to 10 amps through this at most, and we're only putting 20 amps through this entire battery pack, so 7 amps going across each one. I could have 3 of these, so I'm well underneath the capability of that. And then the cells themselves, they only pull about 5 amps total, so I could pull a total of 30 amps across this entire battery cell. Now I'm just connecting up to the BMS. So I used the original BMS that came with it, and then I'm just sticking it back into the case. So overall, it was pretty easy. I was just able to weld it up and put it all back together. The biggest question that I had, there was a on-off switch that I had to double check to make sure that everything was going to be working properly. And I also wanted to make sure that this connection fit exactly the way it was supposed to. And that was the like the do or die moment, but it worked out pretty well. Here I'm just soldering back on the switch. This was the on-off switch. They didn't have a connection for it. And that's it. We have the battery completely back together, and we're just testing positive and negative to make sure that it's both going to charge and that I'm getting the correct voltage, which I am. So that is very good to see. I mean, that was a battery build in under 4 hours. That's pretty good for me. All right, we've got the battery put back together. So this battery has like a gauge here where you can press it, has a light on the back, and it has the switch that we just wired in. So let's go ahead and turn that on. Ha! Got a light. Oh, got a light in the back. Oh, look. Everything works. Perfect. So, battery build looks good, and we have light coming off the bike. Let's see if we can't turn this on. Go ahead and power it on. Nice. Oh, look at that. Powered on. Everything's looking really, really good. So, that was part one. We were able to get the battery back up and running. Looks like we actually have power. We have quite a few things that we need to work on from here. This is going to be another video, but we need to, I think I'm just going to put some tape around that, maybe wrap it with something, and then just put some tape on it. I'm not going to be using the gears a whole lot, I don't think, so we don't need to do a whole lot with the gearing. So that's the gear part. Pedals look fine, chain looks okay, just needs a cleaning, just needs an adjustment. What else needs to happen with the bike? Brake pads look okay. We need to work on, let's see, what else? This 3-speed switch. This 3-speed switch is broken. I need to figure out what's up with that. The throttle is busted right here. All this wiring is exposed down here. We need to fix all that. So we're going to fix the wiring. We're going to fix the cable. This motor doesn't even have a torque arm on it. So I want to put a torque arm on both sides because that's a 750 watt motor. And once we get a torque arm on both sides and replace the 3-speed switch, then we can look at testing it to see if it's going to run. We need to bleed the brakes as well. The brakes go all the way in here, so these need to be bled or just topped up, not quite sure which. Looks like they're running a Tektro with mineral oil, so that shouldn't be too hard. And I think that's about it initially. The front tire needs a little bit of work, but that's okay. I have a spare tire if I need to swap it. I'm going to leave it as is for now. So to recap, we got the battery done. We have some work to do on the bike, but the battery was the main piece that we needed to get online, and it's back online. Everything's working. Everything works exactly the way it should. You can take the battery out and charge it. It works with the original charger, or we could get an aftermarket charger. It doesn't really matter, but it's 48 volt. Everything's working great. Thanks for watching. I'll see you in the next one.